Next, let us say that you need to decompose this fraction into partial fractions. 4x square minus 2x plus 1 by x minus 1 times x minus 2 whole square. So as we have already seen, the corresponding factors will be a by x minus 1. And corresponding to x minus 2 whole square, you have b by x minus 2 as well as c by x minus 2 whole square. So a by x minus 1 plus b by x minus 2 plus c by x minus 2 whole square. Now, as we have seen in the previous shortcut, a can be found out very easily. So a is nothing but, just need to put x equal to 1, right? So if you put x equal to 1, 4 minus 2 plus 1 is 3 by 1 minus 2, that is minus 1 whole square is 1. So a is equal to 3. And the second shortcut is that, so if you have a repeated factor, that is x minus 2 whole square or x minus 2 whole cube, so on. So if you have a repeated factor, the unknown corresponding to the highest power of the factor can be found out using the shortcut. That is, you have b by x minus 2 plus c by x minus 2 whole square. So what is the unknown corresponding to the highest power? That is c, right? So b cannot be found from the shortcut, but c can be found out using the same shortcut that we have discussed. So if you want c, what you just need to do is, you need to equate x minus 2 equal to 0, x is equal to 2. So you just put x is equal to 2, neglecting this term. So if you put x equal to 2, you have 16 minus 4, 12 plus 1 is 13 divided by 2 minus 1 is 1, that is equal to 13. So a equal to 3 and c equal to 13. So a and c can be found using the shortcuts. So b has to be found using the LCM method, but once a and c are found out, you have only one unknown, it is very easy to find. So you just need one equation. So I hope you are understanding the second shortcut. If instead of linear, if you have a repeated linear, the unknown corresponding to the highest power can be found using the shortcut. The unknown corresponding to linear can be found using shortcut 1. The unknown corresponding to the highest power of a repeated factor can also be found out using the shortcut. So I hope these two shortcuts will be very useful to you when you deal with problems on partial fractions. So once you understand these partial fractions, let us see how you can use these partial fractions in integration. So how does these partial fractions simplify our integration process?